Hello everyone, welcome to my channel. And today I am going to explain about plastic and rubber as a packaging material. In last video I have explained glass as a packaging material and quality control of glass as a packaging material specifically for parenteral formulation. Let's see learning objectives. So after going through this video, learners will be able to understand about types of plastic and rubber, their properties and application for parenteral preparations. Start with plastic. What do you mean by plastic? So plastic is any material that contains an essential ingredient, one or more polymeric organic substance of large molecular weight. If we consider the classification, it is either thermosetting or thermoplastic type. Thermosetting is those plastic, when subjected to heat, normally will become infusible or insoluble and such cannot be remelted. They are generally used for construction of closures. Another one is thermoplastic. Thermoplastic are generally rigid at operating temperature but can be remelted and reprocessed. They are generally used for construction of container and they are choice of material for large volume parenteral. If we consider example for thermosetting plastic, it is silicone, epoxy. If we consider example for thermoplastic, it is high density polyethylene, low density polyethylene, polypropylene. Next is why plastic is an alternative for glass. In past, generally, glass vials are the primary container of choice because of their excellent gas and moisture barrier properties. Not only this, extensive knowledge for filling, processing and sealing is available for glass. So large number of glass containers are readily available in market. But glass may not be the best solution for all chemicals or biological products because glass contains free alkali and trace metals that may leach into the product. So that may affect the shelf life of product. Another is protein and peptides that can be readily absorbed on the glass surface and can be denatured and become unavailable for treatment. If we consider pre-filled syringe made up of glass, the potential leachables like silicone, tungsten and adhesive can affect stability of biopharmaceutical product. Glass may break during processing or transportation and when stored at low frozen temperature. And because of all this, plastic becomes choice of component with time for container of parenteral product. Now, advancement in plastic. Cyclic olefins. Cyclic olefins are prepared by additional polymerization of monocyclic olefins, cyclobutane or cyclopentane or bicyclic olefins such as norbornene. So polymerization of cyclic olefins can be done by two methods. First one is chain polymerization, which produces cyclic olefins copolymer, and another is ring opening metathesis polymerization. After hydrogenation, it produces cyclic olefin polymers. So why cyclic olefin is a choice of polymer with respect to the glass. So if we consider the major features of cyclic olefin in comparison to the glass, first one is it is transparent like glass. So it provides visual inspection of the manufactured product till administration of product to the patient. Next one is sterilization. It can be sterilized via autoclave, radiation sterilization technique and gaseous sterilization technique. It is high break resistance and it has excellent moisture barrier property. Another thing is most of the plastic comparison with the glass has higher number of extractable because higher number of component in formulation, but cyclic olefin polymers and cyclic olefin copolymer have very low level of extractable. They are generally inert and they have low binding tendency. Another one is design flexibility and excellent dimensional tolerance. That means they have good melt and flow property so they can be readily blend into themselves to plastic processing. For example, molding and thermal forming. Another one is they have good chemical resistance to acid, base and alcohol. That's why it is preferred material over glass. This chart shows the comparison of total organic carbon as an extractable from syringe barrel, which is comparison of cyclic olefin polymer, cyclic olefin copolymer, type 2 glass and polypropylene. So this graph indicates that cyclic olefin polymers and cyclic olefin copolymers have least amount of total organic carbon in comparison to type 2 glass and polypropylene. Now, next is principal plastic material which is used in pharmaceutical packaging. First one is low density polyethylene and high density polyethylene. So generally polyethylene is a polymer based on simple repeating carbon and hydrogen molecule that branch out during polymerization to form a polymer with high degree of regularity. So depending upon the branching occur during polymerization process, it decides density and crystallinity of material. On that basis, it is divided into low density polyethylene and high density polyethylene. Properties is low density polyethylene is generally soft, flexible and it is easily stretched. And high density polyethylene is strong, stiff and less permeable to gas in comparison to the less low density polyethylene. Use of low density polyethylene is for squeeze type of bottle for ophthalmic formulation, and high density polyethylene used for solid dosage form, and both high density and low density polyethylene are preferred choice of material for blow fill seal technique. Disadvantage if we consider, they get softened by flavoring agent and aromatic oil. They are unsuitable for oxygen sensitive products. They also absorb antimicrobial preservative agent. So due to absorption of preservative agent, concentration of preservative reduces in a product and it affects the shelf life of product. Another is crack on contact with the organic solvent. Next polymer is polypropylene. So polypropylene is linear high crystalline polymer made up of carbon and hydrogen in very orderly fashion. The stiffness of polypropylene is due to presence of methyl group in crystalline array that differentiate polypropylene polymer from its close relative polyethylene. Properties of polypropylene is it can withstand with the higher autoclave temperature of for sterilization for a limited number of cycles. Generally, it used for blow molded bottle, pouches, laminate and plastic container. Generally, it is used in disposable container and delivery systems. Its transfluency limits its role in storage of parenteral drug and biological product for a longer duration. Next is polyethylene terephthalate. So polyethylene terephthalate is polyester that is a condensed polymer prepared from ethylene glycol and either terephthalic acid or the dimethyl ester of terephthalic acid. Polyethylene terephthalate is high quality thermoplastic polymer that offers good barrier protection, chemical resistance and processing property. It is typically used in packaging drugs that may require barrier protection as in blister pack and blow molded container. Because of its low glass transition temperature, it cannot tolerate autoclave sterilization, but it can hold up gamma radiation, so it is preferred method of sterilization. So radiation method can be used for sterilization of polyethylene terephthalate container. Next is polycarbonate. So polycarbonate is the material which is made up of carbonic acid and is generally produced using an interfacial reaction between dihydric or polyhydric phenols and suitable carbonate precursors such as dichlorocarbonate. Material has limited chemical and scratch resistance and very high water transmission rate in comparison to the other plastic. The resin also have tendency to get yellow with light exposure and with exposure to the radiation sterilization. It is generally used for bottle and container for parenteral application. It is suited material for injection molding process. Polycarbonate shows excellent grip resistance over broad temperature range and enables its use in applications previously open only to the thermoset material. Next is polyvinyl chloride. Polyvinyl chloride is prepared by polymerizing gas, vinyl chloride or monochloroethylene in presence of organic peroxides or inorganic persulfates as initiator. They are generally rigid in nature and they use for laminates for blister, and the main use is for constituents of IV bags. Generally, for most of the PVC preparation, they contain diethyl phthalate as plasticizer, and it has tendency to leach out of the container and it may produce potential health risk. Next one is polystyrene. They are clear, hard, brittle with low impact resistance. They generally used for tubes and amber tin bottle. It is also used for jars, ointment cream with low water content. It is used in drug packaging is limited due to its high permeability to water and vapor. Next is rubber closure. Why elastic closures are required for parenteral product? The reason is elasticity of the closure material allows for preservation of the sterility of the package drug by ensuring tight seal between the closure and the container, and by ensuring adequate resealing of the closure after the penetration with a needle or with a spike in a cases where it is applicable. So elastomeric closures have ideal combination of physical, chemical, functional and biological performance combination with microbiological and particulate cleanliness. In cases to reduce the leaching, closures are coated with Teflon material. So these are some of the diagram of closures and rubber material which is used for prefilled syringe. So if we consider parts of the simple serum closure. So closure consists of the upper portion of the closure, it considered as the flange. This portion is considered as the plug. For flange it is necessary that diameter of flange is same as that of the opening or mouth of the vial. Plug should have diameter sufficient that it prevents blowback and it ensures the tight seal between the container and closure. What is meaning of blowback? Blowback is constriction which is present below the flange. It is called as the blowback and it prevents blowback of the closure from the vial. Another type of closure is lyophilization stopper. So what is specific characteristics of lyophilization stopper? So they consist of opening in between of the closure. Why these opening are placed? So when lyophilization is done, this stopper are halfway closed. That means they remain half open. So when lyophilization proceeds, that means when sublimation takes place, the vapor come out of the closure and reduces the pressure inside of the container. And after lyophilization is complete, the stopper are completely closed. So giving opening in between stopper is to escape the vapor produced during lyophilization process. So where rubber components or elastomers used in pre-filled syringe. So generally they use for the plunger for pre-filled syringe, plunger for disposable pre-filled syringe. They also use for preparation of needle cover and tip cap. So next is type of rubber compounds that are used for application in closures for parenterals. So elasticity is introduced by cross-linking the polymer chains of elastomer base of the material by using cross-linking agent, and this process is called as vulcanization or curing. Using curing agent that makes chemical bond between polymer molecules. First component is elastomer. Elastomers are generally polymer base which is used for the preparation of closure. The rubber compound may either use only one single elastomer or blend of different elastomer. So characteristic of rubber depends upon the type of elastomer we use. Next one is the cure system. So as we discussed, The process of cross-linking is called as vulcanization or curing. So cure system is defined as set of chemicals that take care of the cross-linking reaction. There are many types of cross-linking agents available like sulfur, phenol formaldehyde resins, peroxidicides, and amines. A well-known activation system is zinc stearate and zinc oxide in combination with stearic acid. Some of these accelerators like sulfonamides and thiozols are relatively easily extractable and they produces hazardous effect on the health. So, precautions should be taken using accelerator for the curing system. Next is fillers. What is role of fillers? So fillers generally provide mechanical strength to the rubber compound. Fillers generally used are inorganic mineral material like aluminium, clay or magnesium silicate, that is talc. Carbon black, which is commonly used in other rubber application, is avoided as a filler in parenteral preparation because its ability to link with polynuclear aromatic acid and it may create health hazard. Next is pigments. So as we all know, pigments are used to provide color to the system. So in parenteral application, mostly gray, red or black color is used. The gray color is obtained by incorporating titanium dioxide and minor amount of well-defined carbon black. The red color comes from the use of red iron oxide. Organic pigments are generally not used for closures because they have tendency to leach. Next is other rubber ingredient. So other ingredients are added into preparation to provide some physical properties to the rubber like plasticizers or physicochemical stability of rubber compound like antioxidants or anti-ozonants or the surface state of molded product like migrating plasticizers or wax. Modern parenteral formulation, we use this formulation only if they really need it. In any rate, their extractability will be design factor in development of the compound. So, what are types of elastomer that we use for preparation of parenteral closure? So, first one is halobutyl compound. Long-term contact application of parenteral preparations like for preparation of stoppers or plunger for prefilled syringe and cartridge, generally halobutyl compounds are used. There are mainly three reasons why they are selected or preferred choice of component for parenteral formulation closures. First one is it allows the lowest possible gas permeability of polymer that are available in industrial scale. It has lower absorption characteristics, especially with respect to preservative that are present into parenteral formulation and with lowest leaching ability into a formulation. Second one is it allows using cleanest curing system. That means vulcanization can be obtained using smallest possible amount of curing agent and that makes it low extractable compound. Thirdly, hell-butyl elastomers have low level of unsaturation. That means they have extremely good aging characteristic. This allow working with lowest possible antioxidant level. So aging can be prevented by extractable and leachable issues. Still, we can achieve good shelf life for multiple years. Next is polyisoprene compounds. If we consider L-butyl polymers are excellent in terms of impermeability to the gas and moisture, chemical cleanliness and high stability, but it does not provide satisfactory result when there is high number of puncturing is required. For example, in case of insulin cartridge or growth hormone cartridge, number of puncturing or penetration with the needle is in tens of times and design specifications sometimes are of 100 times. So it is not possible to ensure proper functionality in the sense of adequate resealing of the elastomers and absence of coring with a pure hell-butyl compound. So combination of hell-butyl and polyisoprene compounds are required. So what is meaning of absence of coring? So when needles are penetrated into closer, sometimes part or fragment of closures get breaked from the closure and it come out with the needle. It may get mixed with the drug solution. So coring is nothing but the fragmentation or small fragmentation of the elastomeric closure. So in that case, we have to mix polyisoprene and helibutyl compound. So generally, natural polyisoprene compounds doesn't use for parenteral elastomeric preparation because of its allergenic effect. Synthetic polyisoprene compounds are generally used. Their characteristic, if we consider, they have oxygen and water vapor permeability one or two order of magnitude larger in comparison to the helibutyl material. Polyisoprene compound also require more complex cure system, which often means less pure or higher concentration of cross-linking agent. Residue of the cure system in a number of cases may migrate to the surface of polyisoprene compounds, which is called as the blooming, and aging characteristics of polyisoprene compound need to be improved by incorporating higher level of antioxidant and in case of including anti-ozonants. So combination of polyisoprene and helibutyl compound is required to produce required characteristics of elastomeric closures. Next is coated closures. So sometimes coating is done to prevent leaching of closure material into drug solution. So there are two types of closures available into market which are coated with fluoropolymers. So first type of closures are in that only part of the closure is coated, which is in contact with the drug solution, and other part of the stoppers like top side, side wall, and underside of the flange are remain uncoated. And siliconization is done to prevent sticking of two closures together. Another type of closures which are available is coated by spray coating process, and the coating in this case is thinner and this process enable coating of the entire closure. Since the coating is non-tacky in nature, it doesn't require any kind of siliconization process to prevent sticking of two closures together. There are two approaches generally which are used to prevent sticking of two closer together is anti-sticking mark, which is available on the top of the closer, and another one is the siliconization to prevent sticking of closures together. These are the list of composition of rubber closer which we have already discussed in detail. These are the references. In next video, we'll discuss about quality control test for plastic and rubber and blow fill seal technique for filling and sealing of parenteral product into container. Thank you everyone for watching my video. If any query, you can contact me on given email address.